Hey guys, in this video I'm going to show you how to use the chain rule to find the derivative of a function, and I'm going to walk you through two slightly harder examples. Starting with part A, we've got y is equal to x plus 1 on x all raised to the power of 6. Now whenever you're asked to find the derivative using the chain rule, always start by writing the chain rule formula. And this is dy dx is equal to dy du times du dx. Now looking at the expression inside the brackets, notice that the second term, 1 on x, is not written in exponential form. So what you want to do is rewrite this expression in exponential form. And so rewriting the function y, this is the same as x plus x to the power of minus 1 all raised to the power of 6. From here, we then let u equal what's inside the brackets, which is x plus x to the power of minus 1. And deriving this, we're going to get du dx, and this is going to be 1 minus x to the power of minus 2. And then we need to express y as a function of u, and so y is going to equal u to the power of 6. Deriving this, the y du is going to be 6 times u to the power of 5. Now that we have dy du and du dx, we sub this into the formula and we work out the derivative. And so dy dx is going to be dy du, which is 6u to the power of 5, times du dx, which is 1 minus x to the power of minus 2. We can't simplify any further, so we just replace u back as a function of x. And so this is going to be 6 times x plus x to the power of minus 1, all raised to the power of 5, times 1 minus x to the power of minus 2. Now generally, your answer should not include any negative powers. And so what we need to do is simplify this and change the derivative in a way so that we have positive powers. To do this, we can rewrite dy dx as 6 times x plus 1 on x all raised to the power of 5 times 1 minus 1 on x squared. From here, we can take out 1 on x as a factor from the first brackets and take out 1 on x squared as a factor from the second brackets. And so we can write this as 6 times 1 on x times, and this will become x squared plus 1 all raised to the power of 5, and then this will be 1 on x squared times x squared minus 1. And now using the indices laws, this is the same as 6 times 1 on x to the power of 5 times x squared plus 1 to the power of 5 times 1 on x squared times x squared minus 1. And now cleaning this up, this is going to equal 6 times x squared plus 1 to the power of 5 times x squared minus 1 all over x to the power of 7. Part B, y is equal to x cubed minus 2 on x squared all raised to the power of minus 2. And so looking at the expression inside the brackets, we want to rewrite this in exponential form. And so we can write y is equal to x cubed minus 2 times x to the power of minus 2 all raised to the power of minus 2. From here, we let u equal what's inside the brackets, and this is going to be x cubed minus 2x to the power of minus 2. And deriving this, we're going to get du dx, which is going to be 3x squared, and then plus 4x to the power of minus 3. And now we write y as a function of u, and so this is going to be y is equal to u to the power of minus 2. And so deriving this, we're going to get dy du, which is going to be minus 2u to the power of minus 3. From here, we sub in dy du and du dx into the formula to work out the derivative. And so dy dx is going to equal dy du, which is minus 2u raised to the power of minus 3 times du dx, which is 3x squared plus 4x to the power of minus 3. We can't simplify this any further, and so we bring u back in as a function of x. And so this is going to be minus 2 times x cubed minus 2x to the power of minus 2 raised to the power of minus 3 times 3x squared plus 4x to the power of minus 3. And again, we don't want to have any negative powers in our final answer. And so rewriting this is the same as minus 2 times x cubed minus 2 on x squared, all raised to the power of minus 3 times 3x squared plus 4 on x to the power of 3. From the first brackets, we can take out 1 on x squared as a common factor. And so we can rewrite this as minus 2 times 1 on x squared times, and this will become x to the power of 5 minus 2, and then all raised to the power of minus 3. And from the second brackets, we can take out 1 on x cubed as a factor. And so taking this out, this will become 1 on x cubed times 3x to the power of 5, and then plus 4. And now applying the indices laws, this is the same as minus 2 times 1 on x to the power of minus 6 times x to the power of 5 minus 2 raised to the power of minus 3 times 1 on x cubed times 3x to the power of 5 plus 4. 1 on x to the power of minus 6 is the same as 1 on x to the power of 6, which is equal to x to the power of 6. And so this is going to become minus 2 times x to the power of 6, and we can write the next term as 1 over x to the power of 5 minus 2 to the power of 3, and then this will be 1 on x cubed, and then this will be 3x to the power of 5 plus 4. From here, the x cubed will cancel out with the x to the power of 6, and so finally simplifying this to get to the answer, we're going to get minus 2x to the power of 3 times 3x to the power of 5 plus 4 all over x to the power of 5 minus 2 raised to the power of 3. Which brings us to the end of this video. I hope you could follow through because there was some serious algebra involved. And if you did follow through and you found this video helpful, then click on the like button or comment below and let me know. And don't forget to subscribe to the channel. Good luck, and I'll see you guys in the next video.